Section 12.2 Day 1, we are now going to be finding limits again like we did in Section 1. Only difference is we're going to be finding these algebraically. So if on the quiz or the test you have a calculator handy, you might get a problem like we had in Section 1 where you are doing things with the calculator making the table. If you have no calculator, that means you are probably doing a lot of Section 2 stuff where you are solving it algebraically and not using a calculator to solve it. Alright, so taking a look at 5 problems. The first one asking to find the limit as x approaches 5 of that particular rational function. Next one, similar, x approaches limit as x approaches 1 of this particular function. Finding the limit as x approaches 0 of, you see the radical in it, that should be a big clue as to what to do to it. Just like I don't see a radical in it, so there's probably a big clue as what I should do there. Limit as x approaches 0 of, and then you see you have a compound function. That's kind of, again, that's a clue. At least kind of tells me what I probably should do to it. And then the last one, we'll use a calculator for this particular one, finding the limit as x approaches 0 of that function. Alright, so the first thing, of course, you're supposed to do when you're given a problem is, can you take that number and simply substitute it in? Meaning, will it be undefined? So if you plug 5 into the denominator, sure enough, it's going to give you 0. Which means I can't plug it in by direct substitution, which also means I'm either looking at probably an asymptote or a whole. So algebraically, we're going to figure out what to do. I do not see a radical in it, so it kind of tells me to do my factoring and cancel, or they call it the dividing out technique. So I look at the denominator, I can see sure enough it would factor into x plus 5 and x minus 5. And if I look at the numerator, I'd say that's really close to that. I can factor out a negative 1 here, and that would give me a positive x and a negative 5, and now these two are exactly the same, which allows me to cancel it. So really, what am I trying to find the limit of? I'm trying to find the limit as x approaches 5 of negative 1 over x plus 5. These two things are the exact same graph, other than this one doesn't have a hole in it, this one does. Otherwise, they are identical. If you were to graph both of them with your graphing calculator, they look exactly the same. Like I said, this one has a hole in it, this one doesn't. We have taken out the hole, or gotten rid of the hole, and of course that's the problem. This particular term is the reason I couldn't just plug the 5 in, because it made that 0. Now that I've canceled that, notice that I can take 5 and I can plug it in the denominator, and I no longer have a function that's undefined. So that's how we do this algebraically. Now I plug the 5 in, and I get negative 1 in the numerator. 5 plus 5 gives me 10. There is the limit as x approaches 5 algebraically. Same thing you would get if you used the calculator and made the table of values. Alright, so I look at the second one, and I notice kind of the same thing. They gave me the limit as x approaches 1. I ask myself, can I plug 1 in the denominator? I can, but it's going to make the denominator undefined, so that means I can't just simply plug it in there. So algebraically, since I don't see a radical, I need to do my dividing out technique. So I have to try to simplify or factor both the numerator and denominator. And the denominator, don't have to do anything to it. There's no square term. They have nothing in common. The numerator, I can factor that, and you've got two ways of doing it. You're not always going to get one like this where this is a perfect square, this is a perfect square, there's a minus sign between it. So it could factor into x squared plus 1 and x squared minus 1. And then when you look at this one further, two perfect squares, a minus sign in between it. So that means that that one, the x squared plus 1, because of the plus sign, it won't factor, or it would factor into imaginary numbers. But this one can factor into x plus 1 and x minus 1. And now when you look at it, there we go, I got that to cancel. As soon as this term cancels, I know now I can do my direct substitution, because this term is the thing that was causing the problem. So now I'm trying to find the limit as x approaches 1 of, my numerator is x squared plus 1 times x plus 1. My denominator is just a 1. And you can multiply those together if you want to. You really don't need to. If I plug 1 in here, I'm going to get 1 squared plus 1. So 2 times 2, or my limit should be 4. Now, like I said, you're not always going to get a function like this where you can factor doing it that way. You may have to do synthetic division. So this would be 1x to the 4th, 0x to the 3rd, 0x squared, 0x, and then negative 1. And then if you think about this for a second, I'm trying to factor it. Well, the back number is only 1. So it's either positive 1 or negative 1, the only things that are going to work. And really, if you think about it, you know this has to happen. If this doesn't happen, I'm not going to get this x minus 1 to cancel. And if I don't get this specific x minus 1 to cancel, I'll never be able to plug 1 in. So that kind of tells me you need to be trying 1 here. So now you would run through your synthetic division, drop the 1, multiply and add, multiply and add, multiply and add, multiply, and sure enough, it worked. Remember how this factors. This represents x minus the number, so x minus 1. Since this was to the 4th power, this would be to the 3rd, plus 1x squared, plus 1x plus 1. And now that is over x minus 1, and you got this to cancel. Now you say that's not the same thing as this. Well, if you multiplied it out, it is. You don't need to multiply it out. As soon as this thing cancels, you can stop worrying about factoring. You can go ahead and plug in 1 to this, and you'll also get 4. That's the way I would probably think of it. Yeah, it worked this time that I could factor with perfect squares, but this is the way I would think of it. It was telling yourself probably need to know how to do synthetic division. Alright, the third one, again, asking us to find the limit. X approaches 0 this time, and of course if I plug 0 in the denominator, it's going to give me something undefined. So, algebraically I have to solve, and this time I don't want to factor and cancel. I specifically see the radical, so that tells me to rationalize the numerator. In other words, you're going to multiply both numerator and denominator by the conjugate of the numerator. So it's x plus 4 plus 2. And as long as I do it to both numerator and denominator, really I'm just multiplying by a fancy way of multiplying by 1. So I'm now going to have the limit as x approaches 0 of, if I multiply out the numerator, remember I'm foiling now, I have quantities, multiplying those two together should give me just x plus 4. The beautiful news is these are conjugates, so the insides and outsides are going to cancel. The last would give me negative 4 divided by, and rule of thumb, don't ever multiply out the denominator, always leave it factored like this, and I'm going to show you why here. Alright, so I end up with that. Now you probably all can see what's going to happen here, but my point is, why do I not multiply out the denominator? Remember what the goal is. The goal is yes, find the limit, but I want to plug 0 in. I can't do it because of that x. So I want to leave that x factored by itself, because unless this thing cancels, I'm never going to be able to plug 0 in. So my goal is to get rid of that x. Now if you look at the numerator, of course I've got 4, negative 4, they cancel, so showing every little step here. I'm going to have the limit as x approaches 0 of just x divided by x times this quantity of square root of x plus 4 plus 2. And now, of course, if I look at the numerator and the denominator, I can see that the x's will cancel. And really, I'm looking at the limit as x approaches 0 of 1 divided by that quantity. So the square root of x plus 4 plus 2. And now, the second that this x is gone and it cancels, now I can take 0 and plug it in for x. So now I'm going to get 1 in the numerator divided by 0 plus 4, the square root of 4, which is 2, plus 2, my limit is 1/4. So anytime you're doing a problem where you're not allowed to plug the number in and you see the radical in it, that means you're going to want to rationalize the numerator. Alright. The third strategy that you could use if you ask to find the limit as x approaches whatever number and you can't plug that number in is just plain old simplifying. This is a complex fraction that tells me to simplify it, and if I simplify it correctly, this x will probably disappear. Remember, that's the goal. This x has got to go away. When I get that to cancel, I'll then be able to plug x in. So ignoring this x for now, I want to get a common denominator here. So my common denominator would be to multiply this by 2 and multiply this by 2 plus x. So I'm going to multiply by 2 plus x over 2 plus x and 2 over 2. And so now I've got the limit as x approaches 0 of, if I multiply out the numerator, I would get 2. This is negative now, so to make sure you distribute that negative, it would be minus 2 minus x over, my common denominator is 2 times 2 plus x over x. And remember, when you're multiplying by the reciprocal, the 1 would go to the numerator. That x actually is in the denominator. So another way of writing this would be to say the limit as x approaches 0 of, I've got 2 minus 2, so they completely cancel. It would be negative x over, this x is really in the denominator with these things, so it's 2 times x times 2 plus x. And now you can see that these will cancel. Don't forget the negative. So I have the limit now, as x approaches 0, of an implied -1 in the numerator, still have the 2 in the denominator, still have the 2 plus x. And now that this x has finally gotten canceled, now I can take the 0 and plug it in. Gives me the implied -1 in the numerator. I have a 0 here. I get 2 times 2 or 4. It seems to be a common answer for some reason. But I end up with -1/4. Alright, so reminder. If you can't plug the number in and you have just rational functions, factor and cancel, or it's called the dividing out technique. If you see a radical in it, do the rationalizing the numerator. And if it's a complex fraction, just simply simplify it. Alright, the last one, asking us to use a calculator and then just write our answer down. So again, just be careful. You just have to enter the thing in correctly. So go to y is equal to, clear out anything that you might have there, and just type in x squared times the natural log of x. There we go. Go ahead and hit graph. Now I'm trying to find the limit as x approaches 0, so I actually could probably just look at it. And if I look at my graph, I can actually figure out the answer to this, even though I maybe don't know exactly what it's approaching. If you look at from the right, it looks like it's approaching 0, but I'm not 100% sure. Maybe it's dropping underneath. I can look at the table to figure that out. But look what's happening over here on the left. Nothing is happening over here on the left. Remember, by definition, in order for a limit to exist, it has to approach from the left and the right the same y value. Since it's not doing anything on the left, this simply is an answer of does not exist, because there is nothing over here on the left side. And we'll kind of build on that idea a little bit tomorrow. There is your homework help for section 12.2, day 1. If you have further questions, you're always welcome to come in and ask.